Welcome to the 9th lecture on software quality assurance. आज हम बात करेंगे सॉफ्टवेयर क्वालिटी एट्रीब्यूट्स की, उन एट्रीब्यूट्स की जिनका रिक्वायरमेंट्स के साथ ताल्लुक़ है और स्पेसिफिकली रिक्वायरमेंट्स डॉक्यूमेंट के साथ ताल्लुक़ है. रिक्वायरमेंट्स डॉक्यूमेंट is a formal document used to communicate the requirements between customers, engineers and managers. That is, it has a wide variety of people as readers, from very technical, which are designers and requirements engineers, to just application domain experts like users. And it serves as a technical contract between the customer side and the vendor side or the supplier side. This document is also known as Software Requirements Specifications or SRS. Requirements documents are usually written in natural languages like English, Japanese, French, Italian. These languages themselves are ambiguous, so this is a factor that we have to keep in mind while discussing quality aspects with respect to these documents. Requirements documents contain primarily functional and non-functional requirements. Functional requirements are those that capture what is needed by the system, what will be developed or what will be provided by the new software system. While the non-functional requirements capture the characteristics of that new product as a whole. These are typically quality attributes of that software product. And so a lot of quality attributes are captured in these non-functional requirements. The requirements document also contains definitions of other systems that this new software system will interact with or integrate with. There are two different things. The new software system can integrate with existing systems, or it can just interact with existing software systems. So one thing is clear, that the quality of the requirements document is also very important, and we must ensure a high quality requirements document so that we can develop high quality design based on that document, based on that requirements document or SRS. The requirements document also contains sometimes information about the application domain. It sometimes contains information on how to carry out particular types of computations. These kinds of information are not always present in SRS, but depending on the nature of the application domain, these may be kept in the, or may be recorded in the requirements document. And you would also find constraints on the process used to develop software. And so that may be a requirement from the customer that we mention the process of developing software or different processes in developing software. It may also contain information on standards to be followed, and those standards are mentioned in the requirements document. There is another way of looking at requirements, and that is you can classify requirements as either user requirements or as system requirements, and both of them are contained in the requirements document. In some cases, the user and the system requirements may be integrated into one description, that is, they are documented together, while in other cases user requirements are described before the system requirements, and user requirements are stated or recorded as an introduction of system requirements. System requirements are much more detailed and technical as compared to the user requirements. But that's just another way of classifying software requirements. For software system, the requirements document may include a description of the hardware on which the system will be run. And this again deals with those very specific requirements by the customer that forces us to put constraints and limitations on the solution that can be developed using this set of requirements. The requirements document always includes an introductory chapter which provides an overview of the system and the business needs of the software product. So a business case is also present which captures the rationale of the system. Remember, we talked about capturing the rationale of the requirements, and this first chapter usually would capture the rationale for the product or the project. In all requirements documents, a glossary should also be included, which contains descriptions of the technical terminology, which contains description of acronyms used in the application domain. Multiple stakeholders will be using the requirements document, and they need to understand the meaning of different terms in a consistent way. It is very important that the requirements document conveys only one message, and that message is understood by all the stakeholders. Stakeholders have different educational backgrounds, and they may not fully, even if they are from the application domain, if they are familiar with the application domain, they may not be fully aware of all the acronyms used in that application domain. And so having a glossary is a must for any software requirements specification, because it improves the quality of the document manifold. Structure of the requirements document is also very important and is developed on the basis of following information. Number one, type of the system. Is it a very critical software system, or is it desktop application, or is it a client-server information system, or is it a very critical system on which human life depends? It also, the structure of the document is also affected by level of detail included in requirements. Are we documenting requirements in vague, high level or abstract terms? I wouldn't say vague, but abstract terminology, or are we providing very detailed instruction set? The organizational practice, both on the client side and on the vendor side, and budget and schedule for the requirements engineering processes. And this is also a fact of life. We cannot have an unlimited time allocated, an unlimited budget allocated to just requirements engineering processes, but a reasonable amount of budget and a reasonable amount of schedule for requirements engineering processes must be allocated. And depending on the burn rate of the budget and the schedule available, the structure of the documents is surely affected. These were the general things that should be included, or what are contained in the requirements document. Let's discuss what should not be included in a requirements document. Project requirements should not be included in requirements document. Now, what are project requirements? Project requirements are staffing issues, schedules, costs of different activities, milestones, activities and reporting procedures, milestone activities that are of the different activities related to the project, development phases, reporting procedures, who reports to what and what gets reported is not included in the SRS. These are things that are related to project requirements, and there are other documents for those requirements. Design should also not be included in the requirements document, although we do talk about the fact that in some cases we have to include design and implementation constraints, which can sometimes limit the solution space, but overall designs should not be included in requirements document. Similarly, product assurance plans, for example, configuration management plans, verification and validation plans, test plans, and even quality assurance plans should not be part of the SRS. The document will be of high quality if it focuses on what it should be doing. And if we start including other things like project requirements, like designs, and like other product assurance plans in it, then the focus of the requirements document will not be only on requirements, but will become a mother of all documents, which is not the intent. If we want to keep a document cohesive, we must keep the focus on documenting requirements with those things which are necessary and sufficient. Let's look at the uses of the requirements document. There are primarily 5 categories of users. System customers, managers assigned with different tasks. Then you have system engineers that can include designers as well as developers. Then you have system test and system maintenance engineers. The last 2 are key in developing the testing plans and maintaining the software system once it has been given to the customer. Let's now talk about a little bit on what are different requirements for putting together a requirements document. This discussion will then result in the different kinds of attributes that a requirements document must have. A requirement document should only exhibit the external behavior of the software system. That is, it should only specify those things which exhibit the external behavior of the software system. It should not contain implementation guidelines. It should not have a how-to manual. Number 2, it should specify constraints on the implementation. You see, these constraints can help us limit the solution space. In some cases, these constraints can be punitive, that our solution space becomes very small, but in many cases, these constraints help us in putting the boundaries around the solution space, putting the boundaries around a solution. And they help us focus on the development of the solution when we go into the designing and the development activities. The requirements document should be easy to change, and we will see how we can implement this requirement. The requirements document should serve as a reference tool for system maintainers. These are people who are going to keep the system running and fix defects once the software is given to the customer. And so these are the initial set of requirements. there are a couple of more requirements that we can have for the requirements document. The requirement document should have a forethought, should record a forethought about the life cycle of the system. What is the life cycle of the system? That should be included in the SRS. It should contain the responses of undesired inputs, things which are not the normal flow of path. And so, in other words, it should not only capture the functionality, which it has to, but it should also contain information on deviations that would happen when the inputs are not accurate, or if something happens, the deviation path from the normal execution of the software should also be documented. How can we organize a requirement document? Clients and developers may have their own way of organizing an SRS. A company can decide based on the published literature to document their requirements in one fashion or the other. For large military applications, there are published US Department of Defense guidelines on organizing requirements. So there are templates and standards which can be used. NASA has its own sets of organization guidelines, and our own IEEE ANSI, that is American National Standards Institute, has published its standard. And increasingly companies are using IEEE standard because it enables them to work and document requirements in a standard which is well known which is well understood by the industry, and it is well known all over the world. Now you're looking at the IEEE standard 830, which is the standard for organizing an SRS. The first part or first chapter is introduction. The second part or second chapter is general description about the system. Third is specific requirements. So this third section or third chapter would contain all the requirements in the software system. Then we have appendices, and in these appendices we can record the different models that have been developed during the requirements engineering process. And then there is index, and appendices can also contain glossary in them. Now we are going to discuss the quality attributes of software requirements document or SRS. Here you can see 5 quality attributes of the requirements document, and I'll read them. A requirements document should be correct. It should be unambiguous. It should be complete. It should be verifiable. It should be consistent. So these were the first five quality attributes of a requirements document. What we will do is that I will introduce all of them one by one, the quality attributes, and then we will discuss them together after the introduction. So now let's look at the second set of quality attributes of requirements document. A requirements document should be understandable by customer. It should be modifiable. It should be traced. A requirements document should be traceable, and requirements document should be design independent. This was the second set of quality attributes of the requirements document. Now let's look at the third set of quality attributes for requirements document. A requirements document should be annotated. It should be concise, and it should be organized. Let us now discuss each of these quality attributes and relate that with quality assurance aspects. An SRS should be correct, right? We said that. What is correctness? An SRS is correct if and only if every requirement stated therein represents something required of the system to be built. What this means is that you cannot have artificial requirements in the requirements document. Anything that is part of the requirements document and is mentioned as a requirement must be the need of the customer to be part of the software system. Correctness is very important. It is the first quality attribute of an SRS. That an SRS should not have artificial or incorrect or those requirements which represent unrealistic features of the product, those requirements which are really not requirements, just unrealistic wishes of the customers. And sometimes the customers are not able to clearly state what they want, and as a result something incorrect is documented, and we had a discussion on that also before. So correctness is a very important quality attribute, very important quality attribute of an SRS. An SRS should be unambiguous. What does that mean? Because SRS is a document. An SRS is unambiguous if and only if every requirement stated therein has only one interpretation. Again, very difficult task to achieve, but if we follow our requirements engineering process correctly in an iterative fashion, with the help of domain knowledge, with the help of customers, it is possible to develop a set of requirements which are unambiguous. And when requirements are unambiguous, the SRS would be unambiguous. So in other words, you can say that SRS is presentation of the set of requirements. So with the quality attributes that we are discussing are actually the quality attributes of collection of requirements. And in this discussion we see that individual requirements are also discussed. Also part of the ambiguity or ambiguity-free set of requirements is that at a minimum, all terms with multiple meanings must appear in a glossary. So wherever there is a possibility of ambiguity creeping into the requirement set or ambiguity creeping into the SRS, that terminology should be defined in the glossary. And we have discussed this multiple times, that all natural languages invite ambiguity. And so wherever there's a possibility of ambiguity, whenever we are using acronyms, those things should be defined in the glossary. An example of ambiguity would be, and I read this, aircraft that are non-friendly and have an unknown mission or the potential to enter restricted airspace within 5 minutes shall raise an alert. Let me read this again. Aircraft that are non-friendly and have an unknown mission or the potential to enter restricted airspace within 5 minutes shall raise an alert. Now, if you carefully listen to this, you would notice that a combination of the word and with or makes this an ambiguous requirement. If we interpret this requirement, can be interpreted in at least two ways. The third requirement of an SRS is that it should be complete. An SRS is complete if it possesses the following four characteristics. Everything that the software is supposed to do is included in the SRS. Number one. Number two, definitions of the responses of the software to all realizable classes of input data in all realizable classes of situations is included. What this means is that whenever and whatever type of input is provided to the system, that is documented, and the outputs or responses of the system are also documented in all possible scenarios. Remember, we are talking about completeness here. So completeness would require, the definition of completeness that we requires us to document all possible sets of input, or all possible classes of inputs, all possible classes of outputs in all possible classes or all possible situations. The third aspect of completeness, that is an aspect which relates to the structure of the document, is that all pages are numbered, all figures and tables are also numbered, they are named and properly referenced. So in other words, a reader of the document should not be able to find a table or a figure that has not been numbered and named. All terms and units of measure are provided, and all reference material and sections are present. No sections, this is the fourth condition, no sections are marked to be determined, or we write in short, to be TBD. This structure, if we follow this, will tell us that the document is complete, it has been thoroughly reviewed, and all possible interpretations, multiple interpretations, an effort has been made to eliminate that. You have to remember that completeness is a very difficult thing to achieve. Completeness, especially with regards to the inclusion of all requirements of the system, is a very difficult thing to do, especially for large and complex software applications. The next quality attribute that we mentioned was verifiability, that an SRS or a requirements document should be verifiable. An SRS is verifiable if and only if every requirement stated therein is verifiable. Now, as I had said before, an SRS is just here a collection of requirements, a set of requirements. And whenever we talk about sets, we have to talk about individual elements in the set also. So for a set or a set of requirements to be verifiable, we must have individual requirements we must prove that individual requirements are also verifiable. What does that mean? A requirement is verifiable if and only if there exists a finite, cost-effective process with which a person or machine, that is either a human being or a computer, can check the actual as-built software product meets the requirement. Now this is rather a technical term. Let's try to parse it and I'll explain it to you in easy terms. What this is saying, that a requirement is verifiable only if and only if you can ensure that the software product that you have built includes that requirement, and that you can do it in a finite time using cost-effective process. That is, the process of verifiability has to be cost-effective and in a finite time. So that's just verifiability, that you can verify that a requirement exists in the software system. Typically, this is done by empirically showing that the functionality of the requirement exists in the software system. So it is not, for practical purposes, this is not a very complex and difficult thing to do. We also said that an SRS should be consistent. An SRS is consistent if and only if, number one, no requirement stated therein is in conflict with other preceding documents, such as specifications or statements of work. So any document that precedes the requirements document must not be in conflict with the SRS. So if SRS contains requirements which are in conflict with the existing documents, existing facts of life, then the SRS is not consistent. Either SRS is correct or the previous documents are correct, and both of them cannot be correct at the same time. So we have to either ensure that if SRS is correct, then we have to make the changes in the preceding documents, or if the preceding documents are correct, then the SRS has to be modified. This was the first condition. The second condition is that no subset of individual requirements contained within the SRS are in conflict. No subset of individual requirements contained within the SRS are in conflict. So this is like the internal consistency of the requirement set. Conflicts can be of different types, and so we have defined consistency from previous documents perspectives and also from the internal SRS's perspective. But now look at the types of kinds of conflicting behaviors. There is a conflicting behavior that can be captured. There can be conflicting terms used for the same thing, or conflicting terms used to convey different things, or same terms used to convey different things. Then you have conflicting characteristics like performance, like user interfaces and so forth. And then you have temporal inconsistencies dealing with time. Response time can be different, or initialization or other temporal issues are contained in these types of conflicts. So it is very important that our SRS are consistent, our requirements documents are consistent. Otherwise, what we will build based on an inconsistent document would certainly be a low-quality software product. We also talked about the fact that the SRS should be understandable by the customer. Primary readers of SRS in many cases are customers and users. Of course, SRS are read by designers and developers, but customers also read SRS. Customers must be experts in their own areas, but it is not necessary that they are experts in computer science or software engineering. Hardly they would know any terminology, hardly they would have any depth of knowledge about the different terminologies in computer science and software engineering. So this is very important that we ensure that the SRS is understandable by the customers. And whenever we introduce computer science specific or software engineering specific terminology, that has to be explained in the glossary. The next quality attribute is modifiability. An SRS is modifiable if its structure and style are such that any necessary changes to the requirements can be made easily, completely, and consistently. So changes have to be made easily, completely, and consistently. It must have indices, must have table of contents, must have cross-referencing, and appropriate page numbering. This attribute deals with the format and style of the SRS. But it is very important because changes will happen, and if the changes in requirements are going to result in a massive change in the structure of the document, then it will be very difficult to keep up with that document. But we need to keep an SRS as living a document as possible throughout the development life cycle as well as in the maintenance life cycle. We also said that requirements document should be traced. An SRS is traced if the origin of its requirement is clear. That is, we know that these requirements are coming from which earlier supportive documents. An SRS should be traceable, which means that it is written in a manner that facilitates the referencing of each individual requirement stated therein. There are a number of traceability techniques. For example, every paragraph can be numbered hierarchically. Every paragraph is not only numbered hierarchically, but only one requirement is documented in one paragraph. So each paragraph would basically consist of one requirement. We have to number each requirement with a uniqueness, or each requirement will have a unique ID or unique number in the SRS, so that we can say that requirement number 1 or requirement number 1.1 or requirement number 1.1.1, and each of them will be a separate requirement. We can use a convention of documenting the mandatory requirements and the desired requirements and facts in using shall statements or should statements and will statements that we had discussed earlier. Now, there are 4 kinds of traceabilities. Number one is backward from requirement traceability. Backward from requirement traceability. This means that we know why every requirement in the SRS exists, and we trace it from the requirements back to from where it comes. Okay. Then we have forward from requirements traceability, which implies that we understand which components of the software satisfy each requirement. So if we are at the requirements here, we move forward and we know that these requirements are then implemented by which components. Then we have backward to requirements traceability, which implies that every software component explicitly references those requirements that it helps to satisfy. So if we are here at the requirements, we know here in the design and development that this component exists because of this particular requirement. And then we have forward to requirements traceability, implies that all documents that preceded the SRS can reference the SRS, and that is going back to documents that existed before an SRS was written, and we can relate the statements of work to or sources to the requirements or the SRS. So these are four kinds of traceabilities, and these are a very, very important mechanism for quality assurance, because we then know where the things are coming from, where the things are going to, and if we are in any sort of doubt at any point in the software life cycle, we can go to the origin and find out what the real requirement was. This is not a class on traceability, but this is important to note that traceability helps us in achieving high quality systems, high quality software products. The SRS should be design independent. And SRS is design independent if it does not imply a specific software architecture or algorithm, and it should not. It may contain certain design and implementation constraints, but it should not include specific software architectures and algorithms. An SRS is annotated. The purpose of annotating requirements contained in an SRS is to provide guidance to the development organization. The annotations can be through relative necessity, that is, it is essential, it is desired, or it is optional, or by relative stability, that such and such requirements are stable, such as such requirements are volatile, and that way the designs can be built around those requirements. An SRS should be concise. An SRS that is shorter is better, given that it meets all the other criteria. We don't have to be verbose. We don't have to unnecessarily write long SRS. If an SRS conveys its meanings, it is consistent, it is complete, it is unambiguous, then conciseness is a very good quality attribute. An SRS should be organized, and an SRS is organized if the requirements contained in it are easy to locate. This implies that requirements are arranged so that requirements are co-located. Remember that we talked about the fact that natural languages do not force us to put all the related requirements together, but if they are, and they should be, then finding related requirements becomes very easy. and that is an attribute of an SRS that relates to the organization. Before we end this lecture, I would like to present to you certain phrases that you should look for in an SRS, and you are looking at them at the screen right now. They are like always, every, all, none, never, certainly, therefore, clearly, obviously, evidently, some, sometimes, often, usually, ordinarily, customarily, most, mostly, or etc., and so forth, and so on, and such as. Now, if you pay attention to these phrases, you would notice that these are again sort of confusing phrases. Are there any exceptions? Are there any hidden meanings? Are there any alternatives when alternative paths exist or alternative functionality exists for software products? So whenever you see these phrases, you have to be careful. First of all, as a writer of the requirements document, you should try to avoid them. Therefore, for example, would lead to some sort of conclusion. Clearly is also assuming that some sort of argument has been built and then a conclusion is being reached. Some and sometimes, often, usually, ordinarily, always would have a clause which falls into like else clause or otherwise clause, and there would be an alternative path. And if you see words like etc. and so forth and so on, these are things which are leading to ambiguity. Always, every, all, none, and never are things which are absolute things, and you can have either this way or completely that way. So these are the terms that can confuse or can have different meanings in different contexts. And there are other words like good and fast and cheap and efficient, small, stable, handled, processed, rejected, skipped, eliminated. Then there is if and then but no else. So these words also are areas which you should, when you see them, you should be very cautious on their meaning, all the possibilities. Some would say that some sort of process has been executed. Some would lead to unintended consequences. This concludes our discussion on the quality attributes of software requirements. Each one of them has an impact on the final goal, on the ultimate goal, and that is a high quality software product. We must not ignore any one of them, but we must also remember that achieving all preceding attributes in an SRS is almost. And here I trapped you with the word almost, because that's a confusion itself. So achieving all the preceding documents, achieving all the preceding attributes in an SRS is impossible. Once you become involved in writing SRS, you will gain insight and experience necessary to do the balancing act. And the fact is, there is no such thing as a perfect SRS. Allah Hafiz.